Hi, and welcome to video 2 for section 1.4. This is the second of 3 videos. In the first video, we looked at rational expressions, or what we call a fancy fraction. In this video, we're looking at what's known as compound fractions. So, rational expression was a fancy fraction. Sounds nice, sounds pretty, okay, easy enough to work with. Compound fraction is the more messier version. And a compound fraction, as the name implies, compound meaning multiple. So a compound fraction is a fraction in the numerator. So it's a fraction with a fraction in the numerator. Let me rewrite that. A fraction with a fraction in the numerator denominator, or maybe both. More often than not, it will be both. To simplify these compound fractions, we have two options. Option 1 is find the LCD, the least common denominator of the numerator. Find the least common denominator of the denominator. And then divide the numerator by the denominator, the keep, change, flip like we had talked about. This is a lot of steps. This can get messy. The more steps and the messier it gets, the more chance you have to make one of those quote-unquote dumb mistakes. So I personally don't use this option. Now, as you will see throughout the semester, some of you come to this class having some of this knowledge already, and maybe you had an instructor that showed you this way, and that's the only way they ever did it. So that's the only way you know. Well, guess what? That's fine. I'm not going to mark you wrong because you do it a different way than I might do it. As long as you're using sound math practices and not guess and check, then fine. I have no problem giving you credit for solving it. So if you do it by method 1, that's fine. Keep doing it by method 1. Whatever you find that works for you is the method you should be doing. Method 2, and it's just a couple less steps, so it's a little cleaner, like I said, less chance for me to make a mistake. But I'm going to find the LCD, the least common denominator of all the terms. And then I'm going to multiply all the terms by the LCD. And then once I'm done with that, then I just simplify it. I should have a fairly nice fraction to work with. So let's go with just a sort of straightforward example to start. So I'm not going to be dealing with variables and squares and all that kind of stuff. So let's say I have 1/2 plus 1/3 all over 2/3 minus 1/4. So we'll just deal with numbers to see how does the process work. Then we'll take the next step and we'll do a rational expression or a compound fraction. So with option 1, you would find the least common denominator here, which would be 6. Then the denominator, that would be 12. Convert both of those, add them together, subtract them, then keep, change, flip. Like I said, a lot of steps in there, a lot of chance to make a mistake. With option 2, I'm just looking at the denominators. 2, 3, 3, 4. So what's my least common denominator for this? So let me, just in case, so let me show how do we find a least common denominator in case maybe you've forgotten or maybe it was never taught to you. I'm going to take each of them, 2, 3, and 4. So the factors of 2 are what? 1 and 2. The factors of 2 are what? 1 and 3. So I'm doing prime factorization. So 1 times 2, 1 times 3, and 2 times 2. So that's probably a better way to break this down. I want to factor 1 times 2 into as many prime numbers as I can get. 1 times 2, 1 times 3, 2 times 2 for 4. So the LCD, I want to, in finding the LCD, I want to use the number of the greatest number of times that a value appears for all the different numbers. So for 2, if I start with 1, I have 1, 1 here, 1, 1 here. Well, this is technically a 1 in front of here too. So 1. So because I'm doing prime factorization, let me not even write in the 1. 2 is already prime, 3 is already prime, and then 4 I can factor into 2 times 2. So how many 2's do I have? I have 1, 2 here, none, or 2. I want to use it the most number of times it appears, which is what? It's 2 times. So I need it 2 times in my LCD. Now let's do 3. I have none here, 1 here, none here. What's the most number of times is 1 from here, so I need it 1 time in my LCD. So my LCD would be what? 2 times 2 is 4, times 3 is 12. So 12 is my LCD. So by option 2, to simplify this, I'm multiplying everything 12 times that, 12 times that, 12 times that, and 12 times that. Multiplying every term by 12. When I do that, what cancels? 12 cancels with 2. Leaves me with 6, so 6 times 1 is 6. 12 cancels with 3, gives me 4, so plus 1 times 4 is 4. 12 cancels with 3 gives me 4. 4 times 2 is 8. And 4 cancels with 12 gives me 3. I have a minus sign here. 1 times 3 is 3. So 6 plus 4 is 10. 8 minus 3 is 5. So now I just have a straightforward fraction to work with. 10 divided by 5 is 2. So the original compound fraction I worked with just simplifies to 2. Find the LCD, multiply everything by the LCD, and then it should end up giving you a fairly nice fraction to work with that you can simplify. You'll get the same answer with method 1, but like I said, it's a little more messy, I find. And if you guys need to do some more work with finding LCDs, especially now once we start getting into some of these rational expressions, let me know. We'll work a few examples. So let's look at this guy here. Let's say we want to simplify x over y plus 1 all over 1 minus y over x. So if I do option 2, I need to know what is the LCD for all of these. So I have what? Y, 1, 1, and x. So it's the product of all these, y times 1 times x. So the LCD in this case is just x times y. So that's what I'm going to multiply every piece by. X times y times this guy, x times y times that, x times y times that, and x times y times the last one, last term. So these are all like over 1. So with just the first term, if I multiply xy times x over y, what happens? The y's cancel from top and bottom, and I'm left with just x times x, which is x squared. How about here? 1 times x times y, and I have the plus sign here. So I get plus x plus y. Here, I have xy to start, because I'm multiplying by 1, minus, and now the x is canceled. So I have y times y is minus y squared. So now I want to try to simplify this if I can. So basically factor out any greatest common factors from the numerator, which would be what? That would just be x, and I'm left with what? X plus y. And then the denominator, the only thing I can take out is a y, and I'm left with what? X minus y. And that's it. In this case, nothing canceled, so that's fine. So that's my final answer. Sometimes when you do that, these guys might end up the same, and then you can cancel those and simplify further. So in this case, from what I started with, I can simplify this to just this. X times x plus y over y times x minus y. All right, let's try another example here. So again, we want to simplify. We have x over x minus 1 minus x plus 1 over x all over x plus 1 over x minus 1 minus x plus 2 over x. So we can see this is pretty messy. Hopefully this simplifies to something much nicer. So I'd say go ahead and try this. Hit pause if you want, but first let's all find the LCD to start with. So if you want to do method 1, feel free to hit pause. If you want to do method 2, let's find the LCD to make sure that before you go through all those steps, you have the right LCD. So let's look at all these denominators. So what do we have? We have x minus 1, we have x minus 1, and we have x. So my LCD is what? Well, here I have x minus 1. How many times does that appear? Once, none, once, none. So what did I say like when we were doing the first example with numbers? We want the most number of times it appears. Well, the most number of times it appears in any of these is just one time, which is x minus 1. So now how about x? Well, I have 1x here, none, none, 1 down here, which means what? I need 1 in my LCD. So the LCD is x times x minus 1. You could have multiplied all these together, but it would have been a big mess because we only have 1x minus 1 that we need, and we only have 1x that we need. Now, don't multiply this out. Why? Because why? We should get stuff that cancels out numerator and denominator. So if you multiply this out, you're going to get a giant mess. So at this step, just multiply every term by this. Pieces should cancel out. Then you can go ahead and multiply. So go ahead and hit pause if you want. Come on back, get as far as you can. Hopefully you can get to the end. If not, no problem. Hit play, follow through to where you got stuck, and then pause it again. So welcome back. If you did pause it, hopefully you got the answer. I want to multiply everything here by x times x minus 1. 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 And you notice as I've been doing all these, I've been changing the color of the marker. I would highly suggest that if you're working your homework or if you're working an exam, have like a different colored pencil or maybe a pen. I don't really like using pen on it. If you want to use pen on an exam, it's up to you, but I never like doing that because if you make a mistake, you can't go back and erase. So if you change up the color, you can always buy a couple colored pencils. That way you can put it in there so you're able to match up what you're canceling. So here we have what? X minus 1 cancels with x minus 1, and we just have x times x, which is x squared. Minus, here the x's cancel, so I have what? X plus 1 times x minus 1. With this one, the x minus 1's cancel, and I have x times x plus 1. minus, here the x's cancel, so I have x plus 2 times x minus 1. So now I just have a fraction. And it's just a matter of multiplying these guys out, see what will cancel, if anything, hopefully something. So here I have x squared. This one, so minus, and if I FOIL this, well, what do I have here? I have a difference of squares. So this becomes what? So it's minus, and I would use parentheses a lot. If you have minus something, what are we subtracting? So we're subtracting this whole thing, which is what? X squared minus 1. So it's x squared minus 1. Use these parentheses. This is the other place where I see people make these dumb mistakes and then they get the problem wrong because they didn't distribute a negative sign right. The more you use parentheses to keep track of what's being subtracted, the better off you're going to be. How about down here? X times x plus 1, so we get what? We get x squared plus x. And then we're subtracting. Well, what are we subtracting? If I FOIL this piece out, I get what? I get x squared plus 2 minus 1 is plus x minus 2. So if you FOIL that out, you should get that. But we're subtracting the whole thing. We're not just subtracting x squared. We're subtracting the entire x squared plus x minus 2. So now go ahead and distribute that minus sign. So we have x squared. So minus sign goes to everything. So minus x squared plus 1. And down here we have x squared plus x minus x squared minus x minus a negative 2, which is plus 2. So you can see by using those parentheses to keep track of stuff. Otherwise, if I would have just said minus x squared, this would have been wrong, that would have been wrong, we would have trouble. So now what do we have on the top? X squared minus x squared, they're gone, so I just have 1 in the numerator. X squared minus x squared, they're gone. Plus x minus x, they're gone. And plus 2, so just a 2 in the denominator. So this whole mess is really equal to 1/2. No matter what value of x I picked, as long as it didn't make one of these denominators 0. So as long as I don't pick x is equal to 0 or 1, any other value I pick, if I simplify it, I'm going to get 1/2. And that's all we're doing there. So that's it. That's the end of video 2. Come on back, we'll do video 3 and we'll wrap up section 1.4.